What do we
So I
want
think,
to pick up? You tell me.
so I think there are certain things that I feel okay about, and there are other things that I think I need some more work on.
Okay.
And it's kind of interesting that a lot of these word kind of problems that they propose, that they kind of have within the exam,
Yeah.
I kind of feel pretty good about a lot of them because, like you said, you can solve them through the back solving technique, right?
Right. Yeah. If you can do that, not all
They're not,
problems
yeah,
can be solved.
not all of them, but certainly quite a few of them. You can kind of figure it out.
Uh-huh.
So what I'm kind of struggling with a little bit is if you look at, I think it's question, I want to say like 30, 31, yeah, those basically 30 through 40 type thing.
We jumped to 40 last time.
We did.
We kind of skipped. We skipped 30 through 40.
Yeah. So can we take a look at those?
You want to start on 30?
Yeah.
Okay. All right. There is a methodology for solving equations, and you really want to learn it. I kind of have two rules. Get rid of denominators, get rid of parentheses. So how do I get rid of denominators here? Well, if I multiply both sides by x, I get what?
10x and...
Hold on. Multiply just that. You get 5x over x minus 6 equals 2. Correct?
Yeah.
Now what's the other denominator we want to get rid of? X minus 6.
Mm-hmm.
So let's multiply both sides by x minus 6. That gives us this, which gives us this. Make sure you know exactly how I got to that step, because once you get to this step, I know you can solve it. In other words, once you do no longer have fractions and you don't have any parentheses, then it's a relatively easy problem. So the key is get rid of your denominators and get rid of your parentheses. Now what's the final solution here? What's the last step?
Get rid of the 12 or get the x's on them.
Get the x's on one side, everything else on the other. That's always that step. Gather like terms. And gathering like terms means getting all the x's on one side, all the numbers on the other. So what's the next line I should write?
So 3x equals negative 12.
Which means x equals
negative 4.
There you go.
So just so you said
is one shortcut. There is one shortcut that most students are taught. And what that shortcut is cross multiply. You may have even heard that term.
Yep.
What cross multiplying is doing the two steps that I did as one step. In other words, I'm going to multiply that together and I'm going to multiply that together. So I'm going to end up with 5x equals 2 times x minus 6. That's doing two steps in one. I multiplied both sides by x, then I multiplied both sides by x minus 6. Once you get to this, I'm sure you can solve it. It's a question of getting to the easy equations. And when equations have denominators in them, that's a denominator, that's a denominator, you want to get rid of them. And you get rid of them by multiplying both sides by that denominator. And in this case, I do two steps in one. Multiply both sides by x, and I multiply both sides by x minus 6. To produce this. So, if you are familiar with the concept of cross multiplying, you can do it here. You don't have to view it that way. You can choose to do it two steps. Multiply both sides by x, multiply both sides by x minus 6. That's going to get rid of the denominators also.
Yeah, I mean, I understand it. It's just getting to that point, right? That, like you said, once it gets to 5x equals 2x minus 6.
You're fine from there. I know.
Yeah, it's just getting that.
Well, get rid of denominators. Remember that. You always want to get rid of denominators. Let's say I had the following problem. I had 1 over 5x plus 1 over 7x equals 20. That's a hard-looking problem, right? What can I multiply both sides by such that I get rid of all the denominators? And I don't even need to do it in one step. I can do it in two steps.
The x?
Well, let's start by 5x. The way you get rid of denominators is you multiply both sides by the denominator. In other words, I'm going to multiply both sides by 5x. Well, that makes this term 1 plus 5x over 7x equals 100x. Well, I've made the problem quite a bit easier. I got rid of one fraction. Now, what do I want to multiply both sides by now to get rid of the other denominator?
7x?
Yeah. So I'm going to multiply the entire left side by 7x and the entire right side by 7x. Well, now that gives me 7x plus 5x, because the 7x cancels with that, equals 700x squared. Well, that's much easier to deal with than fractions. It's the fractions that give everybody problems. So your first goal should be to rid yourself of the fractions, which means getting rid of the denominators. Secondly, get rid of the parentheses. Once you get rid of denominators and parentheses, you generally have an equation that's fairly easily solved. Okay? Ready to go on?
Yep.
Not quite sure at what pace you want to go here. You kind of, if I'm going too fast, slow me down. If I'm going too slow, speed me up. All right. Another very similar problem. Notice that I have one fraction equals another fraction. When you see that, think cross multiply.
Okay.
Multiply that, what do you get?
So 8x.
Not, well, which one are you multiplying first? If we're multiplying that, we
Yeah.
get 4 times x, that's 4x. Plus 8. That's what that times that is 4x plus 8. Now multiply the other side.
6x minus...
It's 6x squared. You got to multiply the 2 times the 3, and you also have to multiply the x times the x.
So 6x squared minus 4x.
Correct. Now just combine like terms. In other words, this is automatically easier, right? No denominators. When you don't have any denominators, equations are much, much easier to solve. So, what's the next step?
So 6x squared plus 8.
What we're looking at here, and it's important that you recognize these, is a quadratic. We have an x squared term, we have an x term, and we have a number. When you see a quadratic that has an x squared, an x, and a number, you want to get everything on one side, 0 on the other. So, okay, I'll start with 6x squared, then I'm going to subtract 4x to get rid of that x, which means I'm going to have minus 8x. And then I'm going to subtract 8. And after I subtract 4x and 8, I'm left with 0. Okay, now we have a relatively simple quadratic to solve.
Okay.
What's the first step in solving this quadratic?
You put it into the quadratic.
Not yet. No. Quadratic formula is the last result. The first result is try to factor it. And when you're trying to factor something, take the greatest common factor out first. That's always going to make it easy. Well, I can take a 2 out, right? Because I can divide each term by 2. Now, notice that 2, I can divide both sides of this equation by 2, and the 2 disappears, because 0 divided by 2 is still 0. So now, all I have to do is factor this simpler quadratic. Well, I know that 3x squared can only be broken up into 3x times x. I know the signs have to be opposite because I'm looking at a minus 4. That means the signs have to be opposite. But in this case, opposite plus minus is not the same as minus plus, so I have to allow for both of them. Now, I'm looking for factors of 4, and I have to produce that middle term. Well, there's a lot of possibilities here. How am I going to produce a minus 4 in the middle? Well, let's see. If I do 2 and 2, that'll give me 6 and 2. Okay, that'll do it. If I do 2 there and 2 there. Incidentally, when you're factoring, it's a trial and error process. Always. In other words, I don't know. I'm just going to start trying factors of 4. I know that these two numbers have to multiply to minus 4. I know that for sure. Now the question is does this produce this middle term? And the answer is yes, it does. In other words, multiplying those two together give me plus 2x. Multiplying the outsides together give me minus 6x. That gives me minus 4x. So I know that those two are my solutions. Now, those are the two factors. I've taken this problem and I've created it a quadratic that I was able to factor. Now, what are the answers? And it says choose two answers. Well, if I get 3x plus 2 times x minus 2 equals 0, how do I solve that? When two numbers are equal to 0, what do? I should say when the product of two numbers are equal to 0. You set each one to 0. It has to be. You cannot multiply two things together and get 0 unless one of them is 0. That's the only way you can do it. You can't multiply 1/10 by 10 and get 0. You can't multiply any two numbers and get 0 unless one of them is 0. That's it. That's the only way it works. So the way I solve this is by setting each one equal to 0. So I set x minus 2 equals 0, which gives me a solution of x equal 2. And I set the other one equal to 0, and that gives me a solution of x equals minus 2/3. So x equal 2 and x equal minus 2/3. Well, there's the x equal 2, and they want choose two answers. There's the minus 2/3 there. So any of these problems that have denominators, think automatically your first step, try to get rid of the denominators. And if you have two fractions, in other words, if you have one fraction on the left and one fraction on the right, then the first step is cross multiply. And then that gets rid of both denominators in one step. And once you get rid of the denominators, the problem becomes easier, although not a lot easier. This is still a relatively difficult quadratic to factor. But factoring quadratics is definitely something you're probably going to need to be able to do consistently. Now, these are easy. If I have b to the x divided by b to the y. Notice the b's are the same. If your bases are the same, then that's equal to b to the x minus y. Well, that's what we have here. We have the same base, which is x. So what's the answer? X to the what? Subtract the exponents.
So would it be 16 minus 8?
No, it'd be 2/3 minus 2/5. That's what this means. In other words, I've got the same base, which is x, and I got different exponents. And I'm doing division. Well, when you're doing division, you're always going to do to the exponents one level less mathematically. Subtraction is one level less than division. Okay. Now, I still got a problem. I got to subtract those two oddball fractions. Well, how do I subtract 2/3 minus 2/5?
You have to put it into the lowest common multiple.
What's the lowest common denominator?
I would say 15.
What's this numerator right there going to be?
10.
What's this numerator over here?
6.
Now you're in a position to subtract them. What's the final answer?
4/15.
That's this third answer. I don't have it. I didn't capture that screenshot, but that's the answer. It's x to the 4/15. Is all you're doing. This answer right here is going to be x to the 2/3 minus 2/5. In other words, when you're dividing the bases, you are subtracting the exponents. The one thing to kind of remember, to help you remember this, you are never doing to the exponents what you're doing to the bases. If I am multiplying the bases,